I got it too. I'm not incompetent.
Okay, welcome guys. It's our first meeting. So a little bit about ourselves if you're not familiar with us. We were founded last year as a group to sort of bring together more interest in the STEM community. So hold little demos like this pretty much every month. And they're all focused around like hands-on learning and something really interesting, as you'll see in a minute. And this is our officer team. So I'm the president.
I'm Andy, I'm a vice president.
I'm Tadalon, I'm the educational coordinator.
Tara, I'm the media specialist.
I'm Forrest, I'm the production manager.
Daniel, I'm the external outreach manager.
I'm Anna, and Snehal's not here, but we're the internal outreach co-managers.
Yeah, so you'll probably see Sneha and Anna walking around telling everyone about it.
Yay!
And we have videos, so Forrest will be in charge of editing the videos. He's a good editor. Tara does all the pictures and Instagram page, which we'll see in a minute. And us three, we're in charge of making all these presentations and designing the experiments.
It will consist of a presentation about a topic in STEM, related visual demonstrations, and hands-on activities, and all meetings will be recorded and uploaded to our website.
So these are some of our socials.
Klein stops talking.
Go ahead and take a picture of this
Yeah.
slide.
And something about the website, because it redirects to a Google site. So if you're logged into your Chrome, you actually can't see it. So if you want to see it, you should log out. So, again.
Cool. So today we're going to be basically cyanotyping, which is making blueprints, as you can see here. So a little background on what cyanotyping is. So it's a process that actually prints like pictures and images in a blue color, like you can see right there. So the color is actually called Prussian blue, which is actually named after Prussian soldiers' uniforms. It's a country that doesn't exist anymore. Also, it's used to develop pictures way back when you didn't have like Photoshop and like whatever else there is. They actually had to like develop pictures in dark rooms. So cyanotyping was one of the techniques. So the first female photographer, Anna Atkins, was actually one of the first people that actually used cyanotyping as like an art form. So what she's most famous for is actually making cyanotypes of like a bunch of algae, and it's in like some British museum, and that's one of the pictures right there. So that's basically what cyanotyping is, just transferring like a picture onto a piece of paper in like a bluish form, kind of like what you would see in like blueprints for a building.
Cool. All right. So to make one of these crazy blue things, what you do is you get a solution made from potassium ferricyanide and iron ammonium chloride or ferrocyanide. Yeah.
You guys like just get in little groups and we'll pass these out.
Welcome to Klein Lab!
Oh yeah, it's gonna be so much fun.
Going for president.
Okay. So after we spread the solution onto one of these, which is watercoloring paper, you can take any negative of a photo, like one of these, on transparent film, or you can get any plastic sheet and draw on it with a Sharpie if you really want to. You put it on top, and then get a UV lamp like one of these. You take one of these, and then you cover it, and then you turn it on, and then wait for 5 minutes to let the UV from the light bulbs irradiate the picture, and then after like 5 minutes, you'll take it off, and then you'll wash it in a bin full of water to get all of the solution off, and it'll come out with a blue negative of your picture.
I'm the internal outreach co-manager.
How about this? My mom. Okay. Ah, you guys drawing something nice?
Yes. Yeah. We're drawing to me.
Like he's drawing it, but.
Okay, come on.
Okay. Drawing of Kristen is going pretty well. He has very uneven eyes.
Shut up!
What are you guys drawing?
We're drawing
Sunset.
Let's go.
Yay! Sunset!
a romantic sunset.
What else should we do?
You can draw more pictures. Here's my dog.
I was just using it.
Drop poop.
That's good.
Drop poop.
Wait, that's good.
Draw the poop.
Do it like that, and then.
Oh, okay. More than names now.
Come out red though.
Rock. Let's see this finished product. All right, dumpling. I did all the work. I'm gonna head out.
Screen protector.
You're actually amazing.
I know. I'm like an artist.
Ours is so much better.
She's slim thick.
They take a lot of pride in their work.
Oh, wait, no. It's like you have to peel it off. Yeah. Peel it off. And then we take it to the. No! It has to develop.
Develop it.
Oh gosh.
Dip it in and like swap it.
Yeah, you can see it.
Go on.
Here, just like move the bucket.
Yeah, just move it from the sides. You don't have to touch it.
Oh wow, it's actually coming through.
They said it was a vampire.
I didn't know what it was. It looked like a vampire with the ears and then
That was a cat.
his cage just left.
Ours is better.
Where did you put my phone?
Oh, is that the
Okay. Whoa, look at that.
Yeah. I really wanted to look like. Oh, you only know that. Oh, you put it in water.
Oh wow! Whoa! Oh, that's good. That's
I
good.
know.
Where do we put it now?
All right, put it on the paper towel.
Because it cut off. Wait, how
That
many?
looks good. That looks good.
I know.
Like I didn't leave it on there. It kind of looks like you're like looking at a trunk.
It is a dumpling.
It's food.
Also, we drew the
Little swish,
SpongeBob.
Anderson. Huh? Little swishy
Like this, back and forth. Yeah.
Ah, swishy.
I think
This is so non-suited. It's bumping everywhere. Big alter ego. Wait.
Because you left it on too long.
Okay, nice. Hey Brian, that's funny.
Thanks for
Hey, good look. Oh, that's clear. That's clear. That is clear.
Got the scrunchie.
Oh my gosh, we should have put a scrunchie in first.
Yeah, so this is, very quickly, this is what happens. So the yellow stuff on the paper is a mixture of FAC, which is ferric citrate. This is citric acid, you probably see it on like the back of your, on the nutrition label, and potassium ferrocyanide. You might notice there's cyanide here. But, so basically what cyanide, like free cyanide does, is it binds to your hemoglobin in your blood, and that's why it kills you, because the oxygen can't bind. But since in ferrocyanide, the cyanide's already bound to the iron, it really isn't that toxic. So you don't have to worry about that.
Wait, not that toxic.
Like,
It won't kill you.
yeah. So the UV light, since it's really high energy, it catalyzes a redox reaction, which basically means there's like electrons jumping around. So you can see down here, this is iron 3. There's a 3 plus here. After UV comes, it oxidizes the carbon into carbon dioxide, and it changes iron 3 to iron 2, which is green. Iron 3 is yellow. And after that, there's like a little internal reaction with the potassium ferrocyanide and iron 2. So you can see here, the iron 2 and the ferrocyanide kind of combine on the paper to produce the Prussian blue. And why this works is because the negative blocks out the UV, so there's no reaction in the areas that's dark, but there is where the light can shine through. And the washing step works because the potassium ferrocyanide and the FAC is water soluble. So the yellow stuff, you can see like when you washed it, the yellow stuff came off, right? But the blue stuff stayed because it's not water soluble. It's an oil, and they actually use it in oil painting. And also, after it's dry, you can use very, very dilute hydrogen peroxide if you want to oxidize it even more and make it a little bit more blue. Also, you might notice some fuzzy edges on some of your prints, like on the sides. So we have a question. Why do you think that happens? Where's Patrick?
Hi. The wavelength of light, like the UV, like whatever that thing is called. Yeah, I don't know because I'm not good at this.
Well, like when you say like you have a light bulb, right, and you hold something really close to it, it gets really fuzzy, like on the wall you're shining the light on, right? And that's because light travels as a wave. Well, okay, light travels as a particle and both a particle and a wave, but this demonstrates its wave-like properties because, like if you imagine like a block here and light shines through, if it's a straight line, it'll just have like a really sharp edge wherever this is here. But instead, it's a wave. So like when it hits this point, it kind of like spreads out. So you get that like little fuzzy effect like right here.
Yeah, that thing.
Yeah. So that's pretty much it. Thank you for coming.
Woo!